Hello and welcome to part 3 of the C programming course. In the previous course, we learned how to use a floating point variable, how to divide float variables. We also learned how to cast between data types. And in this course, we will continue learning some variables right here. So if we run the program as we left it in the previous tutorial, so let me clear this right here, and I will compile and then I will run the program, then we have what we're printing, okay? So we have so far learned what's a char, an unsigned char, short, unsigned char, short, int, unsigned int, long, long, unsigned, long. Okay, awesome. So now that we have learned the first floating point variable, we will go ahead and learn the next floating point variable. Okay, so the next one is a double. A double has 8 bytes. So I will call double I am double. And maybe I will call it a big number like 10,000, I don't know. Of course, this can start way bigger numbers, but this is an 8-byte variable. So I am double. And we also have long double, which I will call I am long double. And this is 12, for example. And this is a 16-byte long variable. Now, depending on the architecture, maybe if you are in an old architecture, 32 bits, even 16 bits, 64 bits, and also the implementation of the operating system, these values can change. So in order for us to know how long a data type is, we will do the following. So we will print f percent %lu, which is long unsigned, and then we'll print a new line, and here we will do size of, which is a function of the C language that enables us to get the size of variable in this case. So we're going to say size of char. So, and after this we're going to put the word bytes. So it will return the size in bytes, right? Okay. Okay, so let's compile and run, and it says 1 byte because a char has 1 byte. Now, the next one, as you may remember, is short, which had 2 bytes. So if you put here short and I compile and run, we have 2 bytes. The same with int. So int, it is 4 bytes, okay? The same with long, long. Long, long is 8 bytes, okay? And now let's do it with float. With float we have 4 bytes. With double we have 8 bytes. And with long double we have 16 bytes. So this is how we check how long is our data types. So great. Now we know how to define variables, how to specify floating point, integer variables, how to create comments, how to do for loops. And now what we will do will be how can we define a number in a different notation, okay? So if I say integer number, so if I say integer number and I set it to 4, and if I print that number, which we have already done this several times, so %d, %d, then a new line, and then a number actually, okay? And when we print the number, as you may expect, 4 will be printed. Now, sometimes we have different notations, like the hexadecimal notation. So what's the hexadecimal notation? Well, apart from the decimal, we have hexadecimal. which has 16 possible values. In decimal, we have 10 possible values. So right here, let me write it for you. So decimal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 possible values. And hexadecimal, we have 16 possible values. We have the first 10 values we have in decimal plus the first 5 letters of the alphabet, 5 or 6, so 6 actually. So 6 letters, so A, B, C, D, E, F. So if 9 is 9, then A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So how can we define? If we want to define a number in hexadecimal notation, we precede it with the 0x prefix, lowercase x. Okay, so 0x prefix. And for example, if I put 0xa, which can be uppercase, lowercase, doesn't really matter. But if I put 0xa, this means I'm defining the number 10. Okay, so if I go ahead and compile and print the number, as you can see, the number 10 is printed on the screen. So this is how we define in hexadecimal. Of course, we can define like A, B, C, D, E, F, which will be kind of large number. Okay, so this is the number, which is 59,375. Okay, so that's the number. So that is hexadecimal. But now, what if we want to define something in binary, which is the most basic form? Okay, so in binary, we have only 2 values, which are 0 and 1. No more, no less, just 2. Okay? So first we have in decimal 10, hexadecimal 16, and in binary only 2. As you may know, computers work in binary. So if I want to define the most basic data type, which is an unsigned char, which is a byte, it's a plain byte. How I do it is we do 0b, okay, and then we define the actual individual bits of a byte. So a byte has 8 bits. So if I want to write the number 0, or if I want to write number 1, for example, I will start by typing 7 zeros and 1 at the end. Okay, so let me check if I have 8 digits right here. So yeah, I have 8 digits. So if I print the number, I will have the number 1. And if I want the number 2, as you may know, I have to do the following, end in 1 0, which means 2 in binary. Okay, so that's 2. And 1 1 is 3. So it's 3, and so on, so on, and so on. And of course, if I put 8 ones, what we have here is the number 255, which is the largest number that can fit in an unsigned char or in a byte. So if I print this, I'll get 255. So now we also know how to print decimal variables, hexadecimal variables, and binary variables. Actually, definitions of variables. So what else do we have to learn? Well, I can now change the content of the number. So that was 255. But if I want to decrease the number by one digit, 1 by 1, how do I do it? Well, the first way I can do it, it will be number equals number minus 1, okay? Which means assigned to number the current value of number, but minus 1. So if we run this, we have 254. So number was 255 minus 1, 254. but this is kind of large to write, and there's a more efficient way. If we want to decrease the number, we can also do minus equals 1, which is exactly the same. What this means is subtract 1 from number and store it on number. So let's run to check if we have the same result. And yes, we have the same result. And lastly, the last way we can decrease it by 1 is number minus minus. Okay? If we run it again, you can see we have still 254, which is great. Okay, now this notation minus equals 1 is the one we will be learning a bit more about this, because this doesn't only work with 1, it can be maybe 5. Okay, so if I subtract 5, as you can see, 250, but it doesn't only work with minus or subtraction, it also works with multiplication, for example, or division or something like that. Okay, so for example, number divided by 5, so 51, as you can see. Okay, so any operation really, or number modulus 5, which is 0 because it's a multiple of 5. Okay, awesome. So now we know how to do this. But what if I want to... So right here I am modifying the previous variable I defined right here. Okay? So what if I don't want this variable to be modified? I want this variable to preserve its value. So for that we have to create a constant variable. It's very simple. In C, we just add the const keyword before the variable definition. So const unsigned char number. And as you can see here, we have an error which says that we are not able to modify it because it's constant. Okay? So as you can see, this variable cannot be modified because it's a constant variable. That can work for any primitive variable. Okay, awesome. Okay, so now what else can we do in C apart from constant? Well, apart from constant, what we can do is C is pretty low level, enables us to control it a lot. So for those who know a bit of computer architecture, you may know that the CPU has registers, okay? And we can control that in C. For example, if we do a while loop, in C to do a while loop, we will say, for example, let's define int loop count equals 0, okay? And we will say while loop count is less than 100, we'll open this and say loop count plus plus. So what we're doing here is that we are using this variable loop count to count the times that the while loop is repeated, okay? But now sometimes we want to optimize the code a little bit more. We want to use the register of the CPU. So instead of loading this from a kind of the way the architecture works doesn't always use the most efficient registers, in this case for a loop. So a loop, you want to run it very, very fast, right? Because it is often repeated lots of times, hundreds, thousands, or even hundreds of thousands of times. So the C programming language allows us to tell the CPU that use this variable in a register. For that we'll say register int loop count. But this, however, doesn't guarantee that it will be used in the register. Why? Well, because of the implementation of the system. So maybe the company that made your CPU, your operating system, etc., 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 has a different implementation. For example, let's say on brand A computer, they will enable you to do this. But on brand B, they maybe won't, or sometimes it will. So it is not guaranteed. Okay? So this was just a quick note, but it's not a really useful feature. At least know if you're just learning. Okay? So that is the register storage class, which means store this variable in a register. Now, we also have the static storage class. How does the static storage class works? Okay, let's do an example right here. We will create a for loop. So to create a for loop, we will write the following. So let me delete all of these to learn how static variables work. So this is important topic, so please take attention. So a static variable, when it's defined in a local scope, like right here, it will keep its value between function calls. For example, if I call a method, just an example right here. So to call a method, I will say void, which is the default, the simplest way of defining a method, which is basically non-return type or absence of return type. So let's say void my method. Since C is a structured programming language, I will define my method before the main method. Okay? And what my method will do, will define an integer n equals 0, okay? And here we will print f %d new line, and we'll print n. And from the main method, we will call my method. We will call it. To call it, we end it with 2 parentheses. This means that these will run right here. Okay? So, if I run this right now, as you may hope, I will get the number 0. Okay? Which is totally normal. Now, what happens if I will call this method inside the while in the for loop again? So you can say for int I equals 0, I less than 10, and I plus plus. So this means I will call the method 10 times. So please move this inside the for loop bracket. Oops, what I did just here, let me check. Okay, so this method will be called 10 times. So if we call 10 times the method, it will print 10 times the 0. In this case, we don't have to, so this method can be called from here or whatever else. Okay, but now what I want to do is after I print this, so I'll go to the method, I want to increment n. So I'll say n plus plus. If I run this again, as you may expect, oops, let me see what's going on. N plus plus. Why is still 0? Well, because every time what I call the method, the int n is set to 0. Another way I could enable to show all the numbers would be to declare the n as a global variable. Okay, so outside the method, right here. If we put that outside the method, we'll go again and run it, and here we can see that the value is actually updated. But sometimes we don't want to do that. We want to put it inside the method, but still being able to preserve the information here. To do that, we will create a static variable. So say static int n equals 0. And we will run it again. And as you can see, it preserved the values of the variable. So what does a static is doing right here? It's kind of mysterious. So what a static is doing is telling the compiler to only initialize this variable once. So it will initialize the variable once and will keep the value between method calls. So we're calling 10 times the method, and instead of recreating this variable, it's keeping the variable value in memory, and then we're doing this. Okay? So the making local variables, which is right here. If you make a local variable static, what it enables you to do is to maintain their values between function calls. Okay? But what if I make a global variable static? Does it even make sense to do it? Well, in C, to do that, if we do that, we won't notice a change. So right here, as in for our code, it's the same being static and non-being static if it's global. But there is a difference right here, which means that if the global variable is declared static, then the variable is accessible only inside this file. So when you create a project, you may have tens or even hundreds of source files. But if you don't want to share a variable between those files, you use the static keyword, and then this variable will be accessed only from this file, which is the c1.c file. So that's the two functions, the two ways of using the static modifier on a variable. Okay? Now, if we want, on the other side, a variable to be accessed from outside this file, kind of making a kind of a very, very global one, we say extern. So if we say extern, then we are making this variable available from outside the source file. Maybe if we create a file that's called c2.c, okay, and we can access this variable from that file, okay? Awesome. So that's it for variables. Now, as I told you, we have different operations: addition, subtraction, multiplication, division, and modulus. We already learned how they work. We also use this modifier to increment in 1 and decrement in 1. Okay? But now, what about if statements? Okay? So what about if statements? For example, I want to print my method. So I want to print this only if a certain condition is met. Okay, so I will put this printf statement inside this printf inside the if statement. So I want to execute this printf only if a certain condition is met. For example, which condition it could be? For example, I will want to print only when n is equal to 3. Okay, so if I compile and run again, so, oh, extern variable, I forgot to delete the extern. Okay, so we go cc and c1, and I have 3, and only print the 3 one. So it still is running all of this, but it's not printing it. It's only printing the 3 when it's in state 3. Now, for example, to check if a number is equal, we use two equal signs. If n is equal 3, or if n is the same as 3. Okay? So now, what if I want to print in every case, but not when it's 3? So I would say if n is different than 3. For that, we use an exclamation mark and then an equal sign. So it will print on every case, but not in 3. So we compile, we run. As you can see, we have 0, 1, 2, 4. So we're not printing in 3. We're printing in every other case, but not in 3. Okay? So what else can we do here? What if we want to print the even numbers or the odd numbers? Okay? So if n modulus 2 equals 0. So what this means? So if n divided by 2 returns 0 as a reminder, this means this is an even number. Okay? So we will print only if the number is even. As you can see, we print 0, 2, 4, 6, 8. Okay? But now, if it's different than 0, it will be an odd number. 1, 3, 5, 7, 9. So as you can see, we can have lots of things. Maybe we want to print only if n is greater than 4. So we're going to say if n is greater than 4, let's print 5, 6, 7, 8, 9, because all of these are greater than 4. Okay, now it could be also be greater or equal than 4. So if you run this, it will print the same but also 4. Okay, the same with less or equal than 4. So this is pretty basic stuff. Okay, so we have greater or equal, less or equal, different. Okay, pretty simple. So what if we want to check for two conditions at the same time? For example, we want to print if the number, if n is greater than 4, but also n should be less than 8. Okay, so greater than 4 and less than 8. So how can we do both checks? So we will use an AND operation. So to say AND, we press two ampersands right here, and we will say if n is greater than 4 and n is less than 8. So which numbers are greater than 4 and less than 8? Well, 5, 6, and 7. Okay, so these are two conditions. Now I don't have only one, I have two conditions that these will check. So if I run the app, it will print only 5, 6, and 7. Okay, now I want to print, what if I change the AND with OR? To say OR, we print two of these signs right here, kind of an AND, the OR sign. Okay, if we do here and print it, what we do is we print everything. Okay, so to make this more clear, we're gonna say if n equals 4 or n equals 8. Okay, so on either case, so remember here, when if n is 4 or n is 8, we will print it. Okay, so it prints in 4 and 8. Okay, awesome. So that's kind of how we can specify what kind of stuff we want to do, we want to print, we want to call, and so on. Okay, awesome. So that's basically how the C programming language works. Now we also have a different way of looking at this kind of stuff. So this can be used in an if, but we also have an else statement. So if we say else, I can print something else. So if it's not 8 or 4, I could print, for example, it is not 8 or 4. Also a new line right here. And if I run this, so for the first one, which is 0, it says it's not 8 or 4, it's not 8 or 4, it's not 8 or 4, it's not 8 or 4. When it arrives on 4, it prints the 4. And it goes to 5, it's not 8 or 4, 6, it's not 8 or 4, 7, it's not 8 or 4, and 8, it's 8. So, and 9, it's not 8 or 4. So we have that. Okay, then we can do also else if. So we can do another if in an else. So if it's not 8 and 4, but maybe it is 5, for example. If n equals 5, we will say here it is 5, okay? And if it's not 8 or 4 or 5, so we create another statement right here. We're gonna say print f, and we're gonna say we want to print it is not 8 or 4 or 5. It is not, okay? So let's see how it is works. Let's compile it and run it. And you can see it's not A45, it's not A45, it's not A45, it's not A45, then it's 4, then it's 5, then it's not A45. So this is how if and else statement works. So this is pretty useful to do logic and control flow operations, okay? So we knew methods and control flow. So that's it for this tutorial. I hope you enjoy it, and I see you in the next one. Bye.